I welcome you back to this series on algorithms analysis and design. And in this video, we are going to talk about the idea behind minimum cost spanning trees. So, what is a spanning tree? Let's start with the notion of spanning tree. So, a spanning tree is a subgraph of an undirected connected graph G that has all the vertices of graph G with minimum number of edges. Okay, so we are given a graph G. Okay, this graph is undirected and it is connected, and corresponding to this particular graph we are supposed to get a subgraph T which has to have two different properties. First of all, it should have all the vertices as the original graph, so this tree will have all the vertices as the original graph G, and it will also have minimum number of edges. Minimum number of edges means only those edges should be there that make sure that this subgraph is connected. Okay, and there must also not be any cycle. So only those edges that satisfy these constraints will be a part of this particular subgraph, and the subgraph that we are going to obtain will be called as a spanning tree. Okay, so these are the two important properties that a spanning tree should always have. First of all, there cannot be any cycles, and it will always be connected graph, which means there is always a path between any pair of vertices. Okay, so let us try to get a glimpse of what spanning trees are all about. So let us say that we are given a graph G. Okay, this particular graph is having 5 different vertices labeled 1 through 5, and there are 7 different edges labeled 1 through 7. What we are going to do is we are going to generate multiple spanning trees for this particular graph. So if I look at this particular subgraph T1, what we find out is that this subgraph is having all the 5 vertices as the original graph, and it is having minimum number of edges because the edges that it is having, it is not contributing to a cycle, but at the same time it is ensuring that the graph remains connected. So this is a valid spanning tree. Likewise, when we talk about the subgraph T2, we find out that it is having same number of vertices as the original graph, and the edges are sufficient to make it connected, and that there are no cycles in this particular subgraph. So which means T2 is also a valid spanning tree. Likewise, when we talk about T3, we again find out that it is satisfying all the 3 different properties. That means it is having same number of vertices as the original graph, it is connected, and it is not having any cycles. So T3 again is a valid spanning tree. So the idea that I'm trying to bring out with this discussion is that for a given graph there can be multiple spanning trees possible. Okay, so any subgraph that is satisfying these 3 properties will be a valid spanning tree. So now that you have understood the basic idea behind minimum cost spanning trees, let us now move on to the problem of minimum cost spanning trees. So one thing that you have to understand is that this problem is defined for a weighted connected undirected graph. So the graph will be weighted, which means each and every edge will be associated with some weights. It will be connected means there will always be a path between any pair of vertices, and it will be undirected. That means information flow can take place in both the directions. Okay, and with this setting, what is the problem of minimum cost spanning tree? Given this particular graph with these different properties, we are supposed to find out a spanning tree with minimum cost. So we already know that corresponding to a graph, different spanning trees are possible. So out of those possible spanning trees, we are looking at the spanning tree which is having minimum cost. That particular spanning tree will be called as minimum cost spanning tree. Okay, so primarily there are 2 different algorithms that we are going to talk about in order to get the minimum cost spanning trees. Now minimum cost spanning trees are also abbreviated as MCSTs. Okay, some of the books they also abbreviate it by using MCST. Okay, so there are 2 different algorithms we are going to talk about. One is the Kruskal's algorithm and the other is the Prim's algorithm. So we will be taking problems from each of these algorithms and we will be solving different problems. So with this we come to the end of this short session. In the next video we will be talking about Kruskal's algorithm and we'll be taking some different problems.